This video is to show you how to solve systems of linear equations using the method of substitution. So substitution is another method for solving a system of linear equations by solving for one variable and then plugging it back in or substituting it back in to the equation to solve for the other variable. So substitution is going to be a great way to solve if one of the variables has a coefficient of 1, or when one of the coefficients divides easily into all the numbers. So if you see an equation that looks like 2x plus y equals 9, this term has a coefficient of 1. So substitution is going to be a great way to solve it, okay? Or if you had something like 2x plus 4y equals 12, and every term is divisible by one of the coefficients. So every term in this case is divisible by 2. This is going to be another time where substitution is a great way to solve. The steps for solving are as follows. 1, you're going to solve one of the equations for either x or y. So you're going to isolate. What's important here is you're not getting a numerical answer. You're solving it and getting an equation. Then what you're going to do on step 2 is substitute that actual equation that you just got from step 1 into the other equation and solve. Then once you've solved it, you are going to get a numerical answer, x equals 5, y equals 2, whatever the case is, and you're going to substitute that back into the other equation and solve it again for the missing variable. Then you're going to write your solution as a point and make sure to check it. And then the last step, just don't forget to classify. So remember, we have 3 classifications: consistent independent, consistent dependent, and inconsistent. So consistent independent is if you have one solution. Consistent dependent is if you have infinitely many. And inconsistent is going to be if you have no solutions. That would be if you had parallel lines. So our first example, we're going to solve by substitution. So conveniently, the second equation has already been isolated for a variable. So we already have y equals x minus 5. Now, once you get a variable by itself, what I'm going to do is I'm going to put this into parentheses, and that's going to help us when we plug it into the other equation. So what I'm going to do now is I'm going to take this and I'm going to plug it into the other equation for the variable y, since that's what I solved for. So the other equation is 7x minus 3, and then I'm going to take the y out and replace it with x minus 5, okay, and then equals 11. So now I only have one variable, and I can solve this for x. So we're going to start by distributing. So we end up with 7x minus 3x plus 15, be careful with your signs, equals 11. Then I can combine like terms. So 7 minus 3 is 4. So 4x plus 15 equals 11. Then subtract 15 from both sides. We get 4x equals negative 4, and then divide by 4. So we get x equals negative 1. Okay? Once we have solved for one of our variables, I can now take that value and plug it into the other equation to solve. Okay, so for this one, it actually doesn't matter which equation we use. We can plug it into the first, we can plug it into the second. It's going to be easiest to plug it into this one because it's already got y on the left-hand side. So y equals negative 1 minus 5, which is negative 6. So y equals negative 6. So that means my solution is negative 1, negative 6. And because I do have a solution, my classification is going to be consistent. And because we have one solution, it is going to be independent. A system is given by the equations x minus 4y equals 17 and 8y minus 2x equals negative 34. So to solve this one with substitution, we're going to have to do a step at the beginning by isolating a variable. So I can look at both of these And the easiest variable to pick is going to be one that has a coefficient of 1. So if we look at this one, our x coordinate has a coefficient of 1, or our variable. So in order to get x by itself, I can move the 4y to the right, and I get x equals 4y plus 17, and now x has been isolated. So now I can take that and I can plug it into my other equation. Now it's very important on this step that you plug it into the other equation. If you plug it back in by accident into the same equation, you're going to get infinite solutions as your answer every single time. So make sure at this step, after you've isolated a variable from one equation, you're plugging it back into the other equation. Okay, so I've got 8y minus 2, and I'm going to replace the x with 4y plus 17 equals negative 34. Oh, ran out of room there a little bit. Okay, so I'm going to distribute the 2. So 8y minus 8y minus 34 equals negative 34. And now combine like terms. Well, when I combine 8y minus 8y, those are actually going to cancel. I'm not left with y, I'm left with 0y, which is just 0. So I end up with negative 34 equals negative 34. In the event that this happens, this is a true statement, so that means that these were actually the same line, and I have infinitely many solutions. So for my classification, this would be consistent because there are solutions, and it would be dependent. If I had gotten to the end of this problem right here, and this was a false statement, then that would mean there were no solutions and this was inconsistent. So on our next example, if we look at this, we don't have any variable with a coefficient of 1. So now what I've got to do is I've got to look at each individual coefficient and ask, can I divide everything in the equation by that number? So if I look at the first equation, can I divide everything in this equation by 7 or by 4? Neither one. Okay, so I can't solve for anything in the first equation. In the second equation, can I divide everything by either 3 or 6? We can divide everything by 3. So what I can do is I can solve this second equation for x. So I'm going to move the y to the right-hand side. So we get 3x equals negative 6y minus 15, and then divide everything by 3. Technically, you can solve for any variable in this problem. You're just going to end up with fractions. Okay, and then you're going to be taking fractions and substituting those into another equation, which will then result in more fractions, and it just won't be a pretty problem to solve. So if we can get this isolated with no fractions, that's going to be the easiest. So now I'm going to take that and I'm going to plug it back in to the other equation, so the one that I did not use. Okay, again, if you plug it into the same one, you're just going to get infinite solutions every time. So I'm going to plug it into the first, negative 7 times x, which is now negative 2y minus 5, minus 4y equals negative 5. I'm going to distribute. So we get positive 14y plus 35 minus 4y equals negative 5. Now we can combine like terms. 14 minus 4 is 10. 10y plus 35 equals negative 5, and then move the 35 to the right. 10y equals negative 40, and then divide both sides by 10. So we get y equals negative 4. Okay, once I have the y coordinate, I can plug it back into either one of these equations at the beginning to solve for x, or again, this one's going to probably be easiest because it already has x by itself. So x equals negative 2 times y, which I now know is negative 4, minus 5. So x equals 8 minus 5, which is 3. So my final solution is going to be 3, negative 4. So for the classification, this would be consistent since I had a solution, and it would be independent since we just had one solution. All right, our next example is very similar. We have no coefficient of 1. So I've got to look at both equations and determine one of them where I can divide everything by one of the coefficients. So in the second equation, I can divide everything in that equation by 2, which means this is what I want to isolate. So I'm going to move the 8x to the right. I get 2y equals negative 8x minus 12, and then I can divide everything by 2. So we get y equals negative 4x minus 6. So now I'm going to take this and I'm going to plug it back into the first equation since that's the one that I did not use. So negative 12x minus 3 times y, which is negative 4x minus 6, equals negative 7, and now I'm going to solve this. So distribute first, we get plus 12x plus 18. And now what we notice is that these are going to cancel. Okay, negative 12 plus 12, it's not x, it's just 0. So what I end up with is 18 equals negative 7. Well, this right here is false. That is not a true statement. So what that means is that I have no solutions, which means my classification is going to be inconsistent.